Let me ask you a question first. Do you think it will rain today? Yeah. Some of you answered yes and a few said no. Do you notice something? Well, the only possible answers for this question is either yes or no, and they are independent of each other. There is the resemblance of Bernoulli trials in probability. The only possible outcomes of a Bernoulli trial are success and failure. Bernoulli trial is an experiment in which the outcome is either a success or a failure. It is like an answer to a yes or no question. The probability of each outcome is independent of the results of the previous trials. The trials of a random experiment are said to be a Bernoulli trial when they satisfy certain conditions. Let's see one by one. First one, there should be only finite number of trials. Second point, as discussed before, trials should be independent of each other. And the third one, each trial has exactly two outcomes, that is success and failure. And the last, the probability of success remains the same in each trial. These are the conditions to be satisfied for a Bernoulli trial. So, we have discussed the conditions to be met for Bernoulli trial. Right. Now, let's see one example to get a better understanding. The question is, suppose a bag contains 10 oranges and 8 apples, and 6 fruits are drawn successively from it with replacement. Now, my question is whether the trials of drawing fruits from the basket is a Bernoulli trial or not. First, we should check whether the number of trials is finite or not. Yes, here we have 6 trials, n is equal to 6. Now, if we consider the event of drawing an apple as success, the event of drawing an orange as a failure, then the probability of success, that is P, is equal to 8 by 18. We have a total of 18, and out of that, how much is the number of apples? It is 8. So, 8 by 18, we'll get it as 4 by 9. Now, which is same for all 6 trials or the 6 draws, since the drawing is done with replacement. Hence, the drawing of fruits with replacement is a Bernoulli trial. Now, what will be the case if the fruits drawn are not replaced in the bag? When the drawing is done without replacement, the probability of success in the first trial is 8 by 18. Now, in the second trial, do we get the same probability? It depends on the fruit that is drawn in the first trial, right? If the first fruit drawn is an apple, we get a probability of 7 by 17. Now, if the first fruit drawn is an orange, what will be the probability? We get a probability P is equal to 8 by 17, one less, right? So, we can see that the probability of success is not the same. In first trial, we got it as 8 by 18. Second trial, we got either 7 by 17 or 8 by 17. So, the probability of success is not the same. Hence, the trials are not a Bernoulli trial. Next, we will learn about an important distribution which is built on the notion of independent Bernoulli trials, where we have a series of trials and each one results in a success or a failure. An important one is the binomial distribution. It is the distribution of the number of successes in n independent Bernoulli trials. Now, let's see the mathematical aspects related to it. First, we'll see the binomial probability formula. The probability of x successes in n Bernoulli trials is given by P is equal to NCX P raised to x into 1 minus P the whole raised to n minus x. Again, we can write it as NCX P raised to x into q raised to n minus x, where x ranges from 0, 1, 2 up to n. Also, what is q? Q is 1 minus p, that is a failure. And this is actually the x plus 1th term in the binomial expansion of p plus q the whole raised to n, where what does the p represents? P represents the success, q represents the failure, and what is NCX? NCS is n factorial by x factorial into n minus x factorial. Thus, the distribution of number of successes, that is x, can be written as shown in this table. This is a table. This probability distribution obtained by giving different values for x from 0 to n is called binomial distribution with parameters n and p. Now, for given values of n and p, we can find the complete probability distribution as shown here. Now, the probability of x successes is denoted by p of x, where p of x is called by the name probability function of the binomial distribution. A binomial distribution with n Bernoulli trials and probability of successes in each trial can be denoted as b of n comma p. Let's see one example. Suppose a fair coin is tossed 10 times. Find the probability of getting at most 3 tails. Let's see the solution. We know the repeated tosses of a coin are Bernoulli trials. So, we are taking x as the number of tails. Now, what is x? X represents a binomial distribution with n is equal to 10 and p is equal to half, 1 by 2. That is the probability of getting a tail. Now, p of x is equal to NCX p raised to x into q raised to n minus x, where x is ranging from 0 to n. Now, what are the values of n, p and q? We have to find it. So, we know there are 10 trials, so n is equal to 10. Now, what is p? P is the probability of getting tail, that is half, 1 by 2. Now, what is q? Q is 1 minus p, or it's a probability of getting a head, that is 1 by 2 again. Now, put these values of n, p and q in this main equation. So, substituting the values in the equation, that is 10cx 1 by 2 raised to x into 1 by 2 the whole raised to 10 minus x. Now, the probability of getting at most 3 tails means what? P of x less than or equal to 3. Now, what is P of x less than or equal to 3? That is P of x is equal to 0, P of x is equal to 1, P of x is equal to 2, P of x is equal to 3. That means probability of getting 0 tail, 1 tail, 2 tail and 3 tail. Now, we have to substitute the values over here. We get 1 by 2 the whole raised to 10 plus 10c1 1 by 2 the whole raised to 10 plus 10c2 1 by 2 the whole raised to 10 plus 10c3 1 by 2 the whole raised to 10. Now, again on solving, taking 1 by 2 the whole raised to 10 outside, we get on solving the final answer as 176 by 1024, which is nothing but, again reducing, we get it as 11 by 64 as the final answer. So, the inference we get from the binomial distribution is that the number of trials is fixed, while the number of successes is a random variable which can take random values. Binomial distribution is used when we want to know the occurrence of an event, not its magnitude. And in real life, binomial distribution is used while taking surveys to know the positive and negative reviews of a specific product or something. Also, they find application in quality control to know the number of defective items in a lot of goods, irrespective of the type of defect, and many more such applications. With that, we have discussed all aspects related to Bernoulli trials and binomial distribution. Now, let's take a quick recap.
Manorama Horizon. Learning made simple.